Hey everybody, I'm Dr. Pavitra, and today our topic of discussion is going to be relative risk and odds ratio. I know this has been a topic that has been repeated multiple times in your exams. So let's go through it and we will be discussing with an example to help you guys understand what it is about, because it's not just about writing your theory, you need to understand when you're reading a paper. Okay. So basically, relative risk odds ratio tries to explain the relationship between an exposure and an outcome. Say you are playing cards with your friends and you have bet on something. What are the odds of you winning? What are the risks of you losing? Correct? So that's your relationship between your exposure and outcome. Are you going to win it or are you going to lose it? So this outcome can be related to from the point of an exposure to the outcome, or you may try to find a relationship between an intervention and an outcome, depending upon which direction goes, meaning exposure to outcome versus outcome to exposure. The type of study, the name of the study will vary, and what you apply to find that relationship, whether it is odds ratio or relative risk, is going to vary. So, what are they and how are they different? Okay, so when you say risk is the probability of occurrence of an event or an outcome. So, how is this calculated? It is outcome of interest, whatever you want, by all the possible outcomes. Whereas odds ratio is occurrence of an event divided by non occurrence of the event. Okay, so understand this. The denominator, if you see, is different in these two. When you tell risk, the denominator is for all different possible outcomes, whereas the numerator is the outcome of your interest. If you are telling odds, it means non-occurrence of the event, and numerator is occurrence of event or your outcome of interest. Okay, so let's take an example. So when you construct a 2 by 2 table or a 3 by 3 table, your x-axis has the exposure, whereas your y-axis has the outcome. Here, we will discuss the example of somebody going to a rom-com movie versus a scary movie, and what are the chances that they can faint during the movie. Okay, so around 64 people have gone to this rom-com movie and 65 people have gone to the scary movie. Okay, in rom-com, 18 has fainted. Let us imagine they swooned looking at the hero or the heroine. Okay. Out of 65 people who went to the scary movie, 29 people fainted. Okay. Overall, 129 people went to the movie, 47 of them fainted, and 82 of them did not faint. Okay. With the same example, we will see and calculate this odds ratio and relative risk. Okay. So, the same example, the table I have pulled it aside here. So, what are the risks of someone fainting if they watch a movie overall? Okay, here we are not dividing into rom-com or scary. So when you tell risk of someone fainting, what was our risk? Risk is outcome of interest divided by all possible outcomes. Correct? Outcome of interest here is what? It is fainting. What are the all possible interests? It is 129. Both fainters and non-fainters. So it will be 47 by 129.36 will be the answer. Okay, mathematics and all I will not sit and do. What are the odds of fainting? What would we say our odds of fainting calculation as? Outcome of interest divided by no outcome happening. Like our outcome of interest is not happening. So in this case, it will be fainters divided by non-fainters, which will be 47 by 82, which will come to 0.57. Do you see the difference now? The risk number is different, whereas the odds number is different. Correct? Odds slightly overestimates it. Okay, so let's leave it at that. Now you want to know what are the risks of someone fainting in a rom-com and someone fainting in a scary movie. That's all. You are taking only this segment now or this segment. Correct? So when you want to look at just one, so what is the risk of somebody say fainting in a rom-com? So what is risk? outcome of interest divided by total outcomes. Correct? 64 people had watched, out of which 18 had fainted. So that is your risk, 18 by 64. Similarly, for scary movie, 65 people watched and 29 fainted. Correct? So that will be your risk. When you tell odds ratio, so outcome happening versus not happening. So if it is rom-com, how will you calculate odds? How many people fainted divided by how many people did not faint, which will be 18 by 46.39. Okay, again if you see, odds slightly overestimates, correct, the risk of fainting in individual ones. But this is not how you calculate for your studies, correct? Because studies like you compare something against other. This is where your A, B, C, D, A plus B, B plus C, all of those things will come into play. So when probability of an outcome decreases, then odds, risk and relative ratio are the same. Okay, so relative risk, odds ratio, chumma I am confusing, no? Just OR and RR, you remember like that here. Okay, so again the same 2 by 2 table when I construct. Okay, x-axis has exposure and y-axis has outcome of interest. Okay, A, B, C, D. So when you write like this, relative risk for an outcome happening after exposure, which is this part alone, will be A by A plus B, correct? When you tell odds ratio OR, it will be A by B, event happening by event not happening. Okay, so this is your relative risk formula. This is your odds ratio formula for an individual exposure. Okay, and a outcome. Imagine if your A is very, very low. Okay, it is too low, where your A plus B will almost be equal to that of B. In that case, what happens? This will also look very similar to A by B. Correct? Because A is very less. So in that case, then your RR and your OR will be very, very similar to each other. It will be equal. Okay. So now let's go back to our same example and let's try to calculate relative risk as to how you will calculate in a study. So when you have risk of fainting, relative risk. Okay, you want to look at the relative risk of fainting for anyone who is going to watch a movie and you want to compare scary versus rom-com. Then you will calculate relative risk for your rom-com and relative risk for your scary movie and you will divide the two. Correct? Because that is what you want to know at the end of the day. What is my risk of fainting watching scary versus rom-com? Because I want to make the right decision. Okay, so relative risk of event in one group versus another group. That is relative risk. Relative to one point, you are comparing the other point. So when you do this 0.28 by 0.44, which is what I have done here, you will get a number 0.63. Okay, which is 63%. When you do as a 100% ka minus, you will get a 37% number. So what does this 63% mean? Okay, so 0.28 here is your rom-com ka fainting relative risk and risk. 0.44 is your scary movie ka risk. Correct? This is scary, this is rom-com. Okay, so when you have an answer of 63%, what it means is that risk of fainting by watching rom-com is 63% of risk of fainting by watching a scary movie. Where you are telling scary movie is 100%, compared to that risk is 63%. Or in other words, you reduce the risk of fainting by 37% if you watch a rom-com. Correct? So this is relative risk. You are relatively comparing your scary movie versus a rom-com. Okay, so this is your relative risk part. This is your A by your A plus B by C by C plus D. All this complicated formula is this. Okay, if you understand the concept, you will be able to reconstruct it when you are writing an exam. Okay, when you are reading a paper, this is how they have calculated. Now let's look at odds ratio, OR. Okay, so when you look at OR, what you want to know? This is the odds of fainting individually. In a rom-com, it is 0.39. Scary movie, it is 0.81. So you want to know the odds ratio comparing scary movie versus rom-com or rom-com versus scary movie. Okay, so when you compare between the two, it will become 0.39 by 0.81 or 39 by 81, which comes to 0.48. In percentage, it is 48%. What does this mean? It means odds of fainting after watching a scary movie is 48%, or rom-com decreases the odds of fainting by 52%. Do you see now how the numbers are different between your relative risk and your odds ratio? Okay, so that's why it is important to know which one to choose for what and what is the relationship between these two. Okay, so what is the relation? If Okay, let's start from this third point. Third point. Let's start from when to use what, and then we will go back to association. So when do you use what? You need to know whether the outcome would have happened, whether the person has been exposed to the risk factor or not. Okay, so why is this important to know? Because for relative risk, you need to know how many have been exposed. Okay, so if you do not have that number, then you can't do a relative risk. Okay, for example, in a case control study, outcome has already happened. You don't know what they have been exposed to. You are trying to trace back in time, trying to find association between different exposures. So in this case, relative risk cannot be used, odds risk can be used. A simple mnemonic is OR, outcome length. You are trying to find which risk caused this outcome. Correct? So this is odds ratio. Okay, but in a cohort study, in a prospective study where you are starting from exposure because you already know this is a risk, and then you are trying to trace it to outcome. In that case, because you know how many people have been exposed and you are trying to see if the outcome of interest is happening, you can use relative risk. Correct? Very simple. Case control la you will do OR, cohort or prospective la you will do RR. Okay. So what is the relationship between OR and RR? One relationship we already saw. Correct? If your outcome rate is very, very low, less than 10% is the event rate, then your relative risk will be equal to your odds ratio. It can be used interchangeably. If there is no association between exposure and outcome, then everything will be 1. Okay, relative risk odds ratio will be equal to 1. If an association is present, you need to know if there is a positive association or a negative association. Correct? So if your RR is more than 1, it means there is a positive association. If RR is less than 1, that means there is a negative association. Okay, but remember, odds ratio always overestimates your um, overestimates until it goes beyond your RR. So for example, if RR lies between these 2 points, okay, whereas less than 1 RR ku OR will be less than RR, more than 1 ku OR will be more than RR. Correct? So these are the relationship. So no association naka both will be 1. If outcome rate is very low naka both can be used interchangeably, and OR generally overestimates compared to that of your RR, both positive and negative association. Alright. So if somebody is asking you to write a difference, these are all the difference. These are points that we have already discussed. It's just that it is easier if it is in a table format for you guys. Okay. So you can take a screenshot of this. So that's it about your OR and your RR. So hope you have understood the concepts between these two. Wait for our next class where we will be discussing different types of study designs, and subsequently we will discuss few other statistics topics also. Okay. Thank you. Bye bye.